We're very fortunate today to have a great panel with us. There's a lot of diverse backgrounds here, both experiment and theory. So I think there's going to be a nice discussion and an informative session. So welcome to the panel and to the attendees. So let me just start by asking the panel to introduce themselves and also say a little bit about your background, and it'd be nice for the students and postdocs to also hear about your career path and how you came to be, in the position you are today. So maybe we can start with Will.
Yeah, hi. My name is Will Oliver, and I'm a professor of electrical engineering and physics at MIT. But I started my career about 20 years ago as a staff member at MIT's Lincoln Laboratory, which is MIT's national lab. It's under the auspices of the Department of Defense. And I spent, a good 16, 17 years there, collaborating closely with the MIT campus, but as a Lincoln person. And then 3 years ago, I was jointly appointed as a professor on campus. So I've seen a bit of the national lab side as well as the academic side. I'm looking forward to discussing more today.
Will, do you also want to tell us a little bit about your technical background?
I'm sorry, about my which background?
Your technical background.
Oh, sorry. Yeah, right. What do I work on? Yeah, so I work on superconducting qubits, and that's vertically integrated from, say, materials and fabrication, design, error mitigation, and high fidelity gates, so control. And our largest circuits today are at 16 qubits for gate model and 24 qubits for quantum annealing. And I also think about high performance classical computing, so cryogenic CMOS and SFQ, or superconducting classical digital logic.
Great, thank you. Let's go to Amir.
So hi everybody, my name is Amir Yacobi, currently at Harvard in the Department of Physics and Applied Physics. It's interesting. I actually flunked physics in high school, and I think if I were to apply to any graduate school, in physics today, there's just absolutely no way I'd be where I am. So, indeed, my career path is very windy. I started actually with a degree in aeronautical engineering, so I actually didn't formally study physics ever. And after spending some time in the aeronautical aerospace industry, realized that I did want to continue studying and decided to bridge the gaps of my knowledge to be able to enter a graduate school in physics. And so I was eventually admitted to the Weizmann Institute, did my master's degree in theoretical condensed matter physics, realizing that I'm not very good at that, and then switching over to experiment. I did my postdoctoral research at Bell Labs when it was still at its prime, and then returned to the Weizmann Institute in Israel as a junior faculty, spent there almost 10 years before joining the Harvard faculty in 2006. And my research currently, I'm an experimentalist. We're mostly interested in developing new ways of measuring quantum systems, and then exploring these new ways to study some interesting properties about these systems. Specifically, we're interested in the quantum of quantum information science in using quantum bits as sensors, developing topological quantum bits, and developing and utilizing superconducting circuitry for learning about, again, interacting with quantum matter and learning about quantum materials.
Great, thank you, Amir. Let's move to Nathan.
Great. It's actually really kind of funny. My background actually in many ways kind of, mirrors at least parts of the trajectories that Amir's ended up going through. I didn't flunk. I got a C minus in high school physics, and hated it so much that I swore I'd never take another math or science course again in my life. And that is a vow that I clearly took very, very poorly. But and afterwards, I found that I ended up falling in love with quantum theory. And I decided that I really just wanted to understand it better, and ended up pursuing a physics degree, the kind of the hard way through my university. Then I kind of, went forward and thought about, going into experimental condensed matter physics, but very quickly realized that I'm awful at experimental work, and nowhere near as smart as I need to be at that. So I did what all dumb people who can't cut it at experiment do, and went into theory. And so after that, I started kind of really getting into theoretical computer science, which is probably what I spend most of my time thinking about now. So right now, I'm a specialist in quantum algorithm development, mainly focusing on algorithms for quantum simulation, quantum optimization, as well as machine learning. But I do a lot of work on anything that I find interesting. I've done a lot of work looking at applying machine learning and Bayesian methods for modeling of physical systems and processing data. I've spent also along the way, I worked for 6 years at Microsoft Research before deciding that I was getting paid way too much money, and switched back to academia and the national labs. So I spent a year with a joint position at the University of Washington and Pacific Northwest National Lab. And currently I have a joint position at the University of Toronto in the computer science department, with a joint position at PNNL, Pacific Northwest National Labs as well. So that's me.
Great, thank you, Nathan. So let's move to our final panelist, which is Andrei.
Yeah, hi, Andrei Petrenko here. I'm the Director of Product at Quantum Circuits Incorporated. We're a full-stack quantum computing company based out of New Haven, Connecticut. So we're a spin-out from the Yale University labs, co-founded by Rob Shulkoff and his colleagues. Full stack building quantum computing systems based on superconducting circuit technology. So my trajectory is so far not as deep as that of the other illustrious colleagues on this call. I did my undergrad at Columbia, got a BA in physics there, and then went into graduate school at Yale, where I did my PhD in experimental quantum computing with a focus on quantum error correction. And then after that, I immediately started looking for jobs in industry or national labs. And there was an opportunity that opened up at Quantum Circuits right around that time. And the opportunity was too good to pass up. The company was just getting started. I would have been the second employee that I joined. And so again, too good an opportunity to pass up. So I joined. Yeah, so it was really a remarkable ride getting to Series A there. I got to wear many hats and do a whole lot of things while we were getting to that milestone as we were growing the company. Today, I'm again, as I said, the director of product. And so a lot of my responsibilities day to day cover running the software team. But also I play a large role in defining our product roadmap, the kinds of features we're going to surface to our customers and so forth. So yeah, it's a pleasure to be here and looking forward to taking part. Thank you.
Thank you, Andrei. And we'll definitely pick your brain more as we go along about the startup world, which I think many of the attendees and also the panelists possibly including myself are not as familiar with. So first, I would like to kind of touch on something that came up on at least two people, which is changing focus from your undergraduate or graduate to your later career path or to postdoc. And this is something that came up in the previous panel as well. So Amir, you mentioned you went from aeronautical engineering to physics, and Nathan has studied physics first, even though he really didn't want to, and then moved to computer science. So I would like to discuss a little bit, kind of taking this opportunity of your background, changing a discipline, but also relating to the interdisciplinary nature of quantum, where even if we don't per se change discipline, in some sense we do, because we have to learn things from other disciplines and we need to understand to some degree at least. For example, if you're a physicist, a little bit of computer science and how computers work, etc. So maybe start with Nathan.
Sure, yeah. So from my perspective, really kind of, the rigidity of it. One of the things that I noticed when I was an undergrad is I really thought that there were these kind of well-defined rigid separations between the different disciplines, right? And that if you really wanted to be an expert in something, what you had to do is you had to begin with the right undergraduate program. Then you had to go to the right graduate program. And to me, I thought there was a much more linear path towards mastery of a particular field than what I've actually seen. What I've really think I've seen in the long run, looking back at it, is actually there's a lot of intangible skills that are really the important things that I've learned along the way, which were really kind of problem solving skills as well as communication skills, learning how to interact with people who come from very different backgrounds and translating the things they know to the things that I know. And those tended to be the most important things I found for learning. And then once those were developed, it kind of didn't matter as much. I mean, sure, there's impedance mismatches, when you've got jargon from one field versus another. I guess that was a bit of jargon in and of itself. But in any case, despite that, with patience and enough effort, I found that you can, and to some extent, I felt that I needed to really branch out and master things that were quite different from what I thought I would originally need to master when I began. So I would just encourage people in general, when they're running into these types of decisions, to not be terribly scared of making a transitions, but be willing to learn from other people and find good people that you can learn from who are in other disciplines when you want to make that transition, because those people will end up saving you months to years if you can find the right people to help you across some of the stumbling blocks while you make those transitions.
That's, I think, really good advice. Thanks, Nathan. Amir, do you have any comments about this?
Yeah, so I think that switching fields is really a very, very important ingredient. I mean, at the end of the day, we are the sum of our experiences. And if we end up having, a lot of depth in one particular field, it's very, very hard to, to continue and become creative. I think that, even though it looks like aeronautical engineering is very far from what I do today. In fact, only these past couple of years where we've started to look at hydrodynamics of electronic systems, exactly these same equations, Navier-Stokes equations that I studied, 20 years ago suddenly become important, and you have some intuition because you've been exposed to that field. This is something that I generally very strongly advise my students and postdocs to switch fields. It could be small switches, it could be large switches. You could change your entire discipline. The switch could be between one experimental technique to another. But generally, to me, if I feel very comfortable in something that I do, I know it's time to switch. Never feel comfortable, because that really pushes you to learn more. When you're uncomfortable, it's when you really learn the most.
Any comments from the other panelists? Anytime any of you, by the way, want to jump in, feel free. I shouldn't have to call.
Yeah, sure. I definitely agree with Amir on this. I might get the attribution wrong, but I think it was Wolfgang Pauli who said that I can't think of anything new because I'm too smart. And I think it means exactly this, that if you get so comfortable in a field and you know everything about it, and you know why everything won't work, then of course you don't try necessarily the things and explore the different directions that lead to the unexpected discoveries. And so it's very important to get outside of your comfort zone from time to time. And yes, it's uncomfortable. It's like wearing a fuzzy sweater, right? But it's important because it forces you to think. And in some sense, it's a type of diversity. And I think if we took a step back and say, yeah, diversity is a good thing. We need a village to build a quantum computer, let's say. And you might be thinking of that as we want many people from many different backgrounds to join us. That's certainly true. But the individual, him or herself, could also be quite diverse in your background and bring a diversity of experiences to this. And maybe one other point, I don't know if this is exactly true, but I certainly tell my students that at any given time, there may be only 5 or 10 good ideas in the world. And what I mean by that is that different disciplines use different languages to say oftentimes very similar or the same things. And so, like Amir said, I think that, aeronautical engineering turns out to, those hydrodynamical equations are brought to bear right now on quantum systems. And I think that it's true that whatever discipline that you may be in currently, that you can use those ideas and use them in another field. And they may be viewed there as unique and new or something that people didn't think of before.
I think that's really great advice from all of you. So next, I would like to discuss a little bit and compare academia, industry, and national labs. And this kind of also brings in a question that was asked. So I'd like to broaden this question and maybe get your perspective on the different things you've experienced and the things you like and don't like about academia, industry, national labs, according to your experiences. So whoever wants, I will. Yeah, sure. Go ahead.
Yeah, sure. I guess, I've at least directly experienced 2 of the 3. I think of it as different lanes. So there's an academic lane, there's a national lab lane, there's industry lane, and they both have, I would say pros and cons to each one. They're different. In the academic life, the research directions are exploratory. There's a lot of freedom. The budgets tend to be smaller, but often we're driven by fundamental discovery in academia, right? Those are definitely pros in my perspective. On the other hand, not the budget part, there's less continuity. That can be a good thing. There's a lot of turnover. People come and go quite often, and that adds to the diversity. But what it means is that doing something at a larger scale where reproducibility is important, that becomes challenging, right, in an academic environment. At the other end of the scale is industry, where things tend to be quite focused, even market-driven, large scale. You have, generally much larger resources, and those could be human resources as well as physical resources. But then, so you can really accomplish a lot if you have the backing of the company. But of course, that's subject to business cycles. And I guess that's probably most pertinent for blue chips. Of course, there's startup companies, and we can hear Andre talk about the experience of a startup company there. The national labs fit somewhere in between. They're definitely larger scale, although probably not as large as industry. They're definitely focused and sustained, and they're less susceptible to the business cycle. So the business may go up and down, but the funding from U.S. government can smooth those things out. So it's said that we're in a hype cycle right now for quantum. That's probably true, and that may go up and down. I certainly hope we don't enter a quantum winter. But even if we start to head in that direction, the fact that we have robust funding from the U.S. government tends to smooth that out. So the national labs can play that role, and they fall somewhere in between, I would say, academia and industry in terms of scope.
Yeah, I could maybe add a little bit. I agree with essentially everything that Will said. As an academic, I often see, I would distinguish between large industry and startup industry. I think, as an academic, I often see myself as, the head of a small startup company. We're in charge of our funding. We need to bring in the money. We're in charge of PR. We need to publish. We're in charge of hiring. We're basically managing a small, on the scale of 20 to 30 person operation. And we are in charge of doing it all on our own. And I'd say, sometimes it's lonely up at the top. We define how much collaborations we could have. But I think the other side of big industry is that you tend to work in groups, and it's a very, very different kind of, it's more what the student would feel inside the group rather than the PI. I think that small startup companies have a lot in common with the academic world, where you are managing a small pyramid and you're in charge of all the different aspects. So I think these are some of the similarities and the differences that I would characterize between the various components. And I agree, national labs are somewhere in between. I think some national labs, you might have to worry a little bit less about funding. There might be some constant stream of money that comes in. Not always, but you're a little bit, you have a little bit more well-defined mission based on the national lab you're in. So maybe a little bit less freedom, but also a little bit less worry of how to manage the operation on a daily basis.
Yeah. So in my experience, in academia, what's really nice is that you really have a lot of flexibility in managing, let's say, your own experiment. I come from a lab where we have these cryogenic fridges, and you can warm up and cool down and turn on the generators, turn off the generators, put in new devices, with a lot of flexibility and change things out. And that makes it for a very creative environment. And so that's one of the things that I really like. But what my sort of work environment was that I ended up working with small groups. There were smaller groups throughout the lab. And so unlike in the company where I am now, there wasn't one big, overarching kind of goal of having a big multidisciplinary team of multiple engineers, of software, mechanical, electrical, all working and focused on a single product. And so those are some of the differences between the two. And it really depends on the kinds of things that you find appealing. And so in the startup world, or whether it's just a small company, I think the part that I find really nice about that is the fact that you do have a team that is working toward that common goal, and it's not a collection of smaller kind of experiments that are more kind of interspersed. And that's one of the things that I really enjoy day to day. Yeah, and kind of building off of something that Will said earlier, one of the things about industry which is a little bit out of your control is things like market forces, and you don't really know what to do about that. It's completely out of your control. There's you don't know which way the stock market's going to go, or how that is going to affect your day to day. So there are trade-offs. There are factors out of your control everywhere. But that's how I would kind of compare and contrast the two. And I've found fulfillment in both environments, just of different sorts.
So one thing I'd like to add is that, I found, having worked in all three of the different lanes, one of the things that really surprised me actually wasn't so much the differences in the mean, but actually kind of like the standard deviation of experiences that you end up seeing between them. So one of the things that I'm relatively confident in saying is that if you look at industry in particular, nearly everybody is capable of finding their dream job within industry, because the breadth of experiences that you can end up getting with some industrial positions is incredibly wide. There are some positions within industry that are more or less 100% pure exploration-based research. Others, which are very much product focusing or spending 100% of your time on it on experiment, and some that are kind of hybrid in between. So it's quite possible to end up finding a position for whatever tastes you have within industry somewhere. The thing, though, that is that you've got to bear in mind within industry is that everything depends very strongly upon the management chain that you're in industry. Well, stock market prices, can end up coming in. They're actually, except perhaps in startup land, where the amount of funding coming in can be life or death in some cases. But for the larger companies, it kind of doesn't really matter as much as the leadership chain above you. And if your manager and your manager's manager supports what's going on, you can have an amazing time. But companies are always one reorganization away from those situations changing. And so this is one of the reasons why, it's very easy to find your dream job in industry, or perhaps not very easy. It's possible to find your dream job in industry, but that dream job will almost certainly change over time. Academia, on the other hand, there's a much narrower set of types of positions, a much more narrowly defined set of expectations. But, and that one is probably the closest one, I would say, to the kind of traditional lane model that we heard, others talk about. The national lab system, what I would say about those experiences over there is that a challenge that you run into is that if you're an experienced person who's capable of easily raising your own funds in a national lab system, you've got a lot of freedom over there. So it almost ends up feeling like as free as many of the other positions. But the deal with most of the national labs, at least at the moment, is that the majority of them don't have enough funds individually in order to be able to support directly all the people that go in, i.e. your salaries usually have to be covered under the funds that you raise. And if you're a junior person coming in, what this often ends up meaning is that you're kind of forced to bounce around between different funded projects in order to make enough billable hours in order to cover your time. So, the national lab system, I definitely agree with Will's statements about it. Once you've climbed the seniority ladder, there's a lot of junior people who can come in, who can get permanent positions that would be difficult to get in some of the other settings. But in order to be happy and be successful in those types of roles, often what people have to be willing to do is kind of more chase the dollars rather than pursue their big ideas. So that's one of the things that I wanted to mention is kind of like the diversity of experiences within each of these different categories. They can be, some of them, particularly industry, but to a lesser extent, the national labs, can be a lot broader than you might have previously thought. And if you're considering going into industry or the national labs, just talk to people, figure out what the managers are like that you're working under and the various other people that you're interacting with. Because for many of you who are listening, there can be some really great options, but you just need to make sure that it's a good fit for you specifically.
Yeah, maybe I can just echo what Nathan said. I think that's exactly right, and a good point that, your management chain, particularly in a national lab and in industry, let's say it makes all the difference. It makes a lot of difference, right? And if you've got a management chain that cares a lot about mentorship and nurturing new people, it's true that, the dollars are really important because you got to pay everybody's salary, say at a national lab. But if the mentality is, look, we're going to bring these new people in and we're going to sign them, we want them to do good technical work for the first 3 to 5 years that they're here before they go off having to, chase after dollars and stuff like that. That's going to make a really good technical experience and help that person grow. And so, like Nathan said, talk to people, find out what the environment's like, because the people who are there, and don't just sample one, sample N. You'll get a picture of what it's like there, and good management makes all the difference.
Yeah, I also had some time in a national lab, and I echo exactly what both of you have said. Great. So there's 2 questions that I think kind of relate to the discussion we're having from the audience. So let's take those. They're a little bit more specific. So Sherry Zhang asks, as the industry of quantum technology is taking off, what are the advantages and uniquenesses of academia, especially in an engineering department? If anybody has a comment for Sherry.
Well, maybe I can just start it off. I think this is an exciting time because quantum engineering is just getting off of its wobbly legs and starting to stand up. I think quantum science has been, around for a good 20 years and will continue to be very, very important going forward. Don't get me wrong. But quantum engineering itself needs to stand up if we're going to build larger scale, reproducible, robust systems, right? And academia has a very important role to play there because we need to develop the curricula and we need to write the textbooks. In fact, first, we need to even develop the abstractions that we need for engineering so that we can train people in different engineering disciplines to contribute meaningfully to quantum computing or quantum information science and technology without necessarily getting a PhD in physics, right? That's the goal. And there's a lot that people need to contribute, and there's a lot of contributions that are needed. And so it's academia's role to create curricula that we can use to train future quantum engineers and, frankly, fill the pipeline of people who are going to go out and be that quantum workforce in 5, 10, 15 years.
Right, and this is, of course, the development of the workforce. This is one aspect where academia plays an important role. The other is, of course, to lead the breakthrough discoveries that are gonna dictate essentially where industry is headed in the next decades. So whereas as things get developed in industry and we're seeing some really major strides on many different fronts there. There are still major roadblocks, and much of these roadblocks may be overcome with quantum leaps, some serendipitous discoveries that take place in an academic environment. So I think the 2 components, both fundamental discovery, pushing the frontier, which will then open up new possibilities in the quantum domain, and developing the workforce, is the role of academia as this new field kind of emerges and transitions from basic science to engineering to academia, to industry, sorry.
Yeah, maybe just to add one thing, I agree with that totally. We often talk about basic science, but the other half of all of our institutes are schools of engineering, and at a school of engineering, they have fundamental engineering as well. So I would put that on par with basic science, that there are like Amir just said, there are fundamental discoveries that need to be made, not just on the science side, but also on the engineering side, if we're going to make quantum systems a reality.
Well, I think that, certainly, I guess there's a question about what form, right, quantum systems are ultimately going to be in, because, there's this big question right now of, okay, is it going to be a problem right now where, the transmon is essentially a sufficient form or substrate, I guess, for quantum computing, that with quantum error correction, in principle, we could scale up to an arbitrarily good device. If that's the case, and that's sort of the path forward, then it seems to me that, you know, a lot of it on the engineering side is going to be a massive injection of funds in order to be able to buy all the control hardware and do a lot of the engineering needed to scale up to very large systems. But on the other hand, I don't think it's necessarily obvious that, you know, the devices 50 years from now are actually going to strongly end up resembling the current ones. And, you know, the purpose of one of the main goals of the engineering departments, I view, is to really probe the new generations of quantum devices that might provide better paths towards this. Because after all, I think a good argument can be made that existing approaches to quantum computing kind of more closely resemble the vacuum tubes of classical computers than the beautifully clean transistors we currently use. And I think that one of the goals of engineering departments really is going to be to see whether or not we can find this kind of quantum analog of a transistor.
One thing to add quickly, we also, you know, as someone who's involved in hiring pretty frequently, we also want to just longer term make it clear to engineers of all disciplines that quantum computing or quantum in general is open to anyone who is not a quantum physicist, certainly not a PhD, but you know, software engineers or mechanical or, you know, again, electrical. It's an option for you guys. You know, please think about it. You're not, you know, this isn't a closed club. So anyway, that's just a minor comment, but I think a very important one because this is going to be kind of a group effort going forward.
Yeah, thanks, Andre, for this. Oh, yeah, go ahead, Ami.
Yeah, one additional comment. I think what we're also noticing is that traditional boundaries between fields are completely getting wiped out. And quantum sciences is cutting across many, many different disciplines, including chemistry, physics, applied physics, electrical engineering, computer science, applied math. These are all part of quantum science. And I think thinking about this field as belonging to one and only one of these is completely incorrect. We need, in fact, all these components in order to make progress. And I think there's gonna, you know, I see it in our own institution, you know, Harvard's Quantum Initiative basically is very inclusive to incorporate many people from all these different departments. There's a new quantum engineering graduate program that's being launched that's attracting people from many, many different disciplines. So I think that it's basically a new cut, a new cross-section across disciplines that is going to be, that is emerging. And I think it's very exciting.
Yeah, I want to touch on something that Andre mentioned, and that connects very nicely to a question that one of the attendees asked. And the question is, if your research is not related to quantum, do you recommend looking for a postdoc as a way to get quantum experience before entering industry? Or are there opportunities to put directly from a PhD to industry if the PhD is not in quantum? So I don't know, Andre, do you want to comment on that since you're hiring a person who hires people in industry, and maybe other people can chime in as well?
Well, like I said, we're certainly not when we're filtering resumes, we're certainly not looking only for PhDs. That should hopefully go without saying, and if it doesn't, I'd like to.
I think that the question is more about someone who already has a PhD, but is not in quantum information science or engineering, and they want to gain some quantum experience. Would a postdoc help them enter industry?
It really depends. It depends on the position that they're applying for. It depends on a number. It depends on a number of factors. I mean, certainly, if they have a PhD in mechanical engineering, but they're interested in being a quantum physicist who's doing work on, you know, designing our, let's say, transmons, then certainly it sounds like a career shift might be necessary there. But if they want to contribute in their field of expertise, then certainly not. But you know, I would also love to hear from everyone else on the panel.
Well, I can say that, for example, at Lincoln Lab, we hire people at all levels, from technical, technician through, bachelor's, master's, PhD. And if you have a PhD and you're thinking to do this pivot to quantum, I agree with what Andre said. It kind of depends on what you're coming in with and where you want to go to. But why not apply to both, right? Like, apply to companies that you're interested in, and also look into some postdoc positions and get to know, what the industry positions can do and what it would look like when you got there. Chances are you have experience that can be brought to bear on quantum problems. And like we were talking about earlier, the diversity there is really good. And we like to pick up people who weren't just born and raised as, transmon qubit physicists. We like to bring in people with a broader range of experiences. But I think again, it's specific to what you're coming in with and where you want to get to. So maybe look into both directions and then make the best decision for you.
I find that, when you're looking at a postdoc, right? A postdoc for me is a really a great experience for you to, in a safe environment, stretch out a little bit beyond your current range of expertise. So if you're interested in kind of building some expertise in a quantum adjacent field, what I'd recommend is, doing a postdoc can be a reasonable way of doing it, but make sure that, you're ideally doing a position where you can reinforce the things that you developed during your PhD, while also stretching out a little bit into the other field and finding sometimes maybe another professor that you can work with who's deeply in quantum to help advise and guide you during the process is a really great way of doing that. But when you're taking a look, again, it depends, as the people said before, it depends on what your background is and what you're getting into. I've seen people who, are trained as computational chemists with no quantum computing background whatsoever, being hired by quantum groups to study quantum algorithms for chemistry. Because the training time to take somebody who's a computational chemist, to teach them the minimum of quantum computing needed to do it, it's pretty quick, actually, surprisingly. Similarly, if you're a programming languages person, there's a lot of interesting things that that companies are interested in developing the various programming platforms that many of them are developing. And so, and this, of course, is absolutely needed in the long run, because if we take a look at laying out an error-corrected quantum algorithm, to do something like a chemistry simulation, we're looking at millions of quantum bits and potentially billions of gates. And there's no way that we can hand optimize that like we presently do. And developing the software tool chain needed to do that and translate a high-level algorithm all the way down to the raw pulse sequences that are being put into the hardware, there's a lot of hard work that needs to be done and a lot of boundaries that you need to work between in order to build the tools that actually facilitate that. So there's a lot of, I think, great stuff that people can jump into in quantum industries without any traditional quantum background. But you can learn these things. For example, when I was at Microsoft, one of the folks there, Dave Wecker, he ended up having amazing impacts kind of across the board, ranging from algorithms to actually even the hardware. And technically on paper, his highest credential was he had an MBA. So you can learn, you can develop, and you can grow. Just pay attention. Look at all of these things, if you're a junior person, as an opportunity to grow. And I'd recommend thinking about the positions that you think will end up helping you kind of grow into the kind of scientist you'd like to become.
Thanks, Nathan. So we have a lot of questions. So let me go to another one that's kind of relating back to national labs industry. So this is about people who are kind of unsure, started thinking they'll want to go into industry, but have been also thinking about national labs. And the question basically is, how easy is it to go from one to the other? And is it easier to go from national lab to industry than the other way around?
Do good science and you can go wherever you want. I think that's pretty universally true. The only thing that I ran into, having transferred back and forth between a bunch of them, is I found transferring into academia from industry was a pain in the butt because I didn't have the teaching requirements that I needed to get an associate prof position. So I had to start on the bottom rung because I didn't have enough teaching background. But transitioning between the other two, quite frankly, if you've got the CV, then I didn't see any problems at all in any order.
Yeah, I would echo that. I think going back and forth between industry and national labs is pretty straightforward. And like Nathan said, I think it's when you try to go from an industry or national lab to academia, it's not impossible, but the easiest, in my experience, the easiest time to do it would be within the first 3 to 5 years when you can come in as a junior assistant professor, or maybe an associate without tenure. If you're thinking about doing that, though, remember that you want to present a good academic case, and that means make sure you're keeping track of your publications and you have a good record. That when presented to a hiring committee at a university, they would say, yeah, this person looks like they're on the academic track, and you would want to just keep track of that while you're at the national lab or in industry. And you can certainly publish in both of those places. But you just want to keep it in the back of your mind, because your motivations at industry and at a national lab may be different than just publishing. Generally, they are. Publishing is a part of it, but it's much more directed research and with a goal in mind, and your focus is on that. So yeah, just keep that in mind, that you want to keep a good academic record if you think in the future you may want to jump back into academia.
Yeah, there's also a specific question for Andre, which is what do you see the focus on quantum error correction in a startup? I guess in your case that's pretty heavy focus, but if you want to comment on that.
Yeah, well, at Quantum Circuits, that is a huge focus of ours. Error correction was one of the linchpins of our architectural approach. So I won't speak to the decisions made by other companies, hardware or software in the space, but for us it's a very important feature because it's obviously essential for scalability and fault tolerance, and so we think that it's essential to get started on it early, to get it figured out early. And so we view it as absolutely critical path.
Yeah, another question that's kind of going more about how to prepare for applications to jobs is for people who have had a winding path and have done different things. How do you properly emphasize that the skills picked up in other fields are useful when applying to a job in a specialized field such as this? I'm not sure if I would call this a specialized field, but anyway, the question, I guess, is how do you emphasize in your CV or in your application the skills that you pick up that are relevant for other things you want to do?
I could maybe comment a little bit about this, some thoughts. I think one of the most important things any one of you has to offer is that you know how to learn. And the fact that you have transitioned between fields demonstrate the fact that you have the ability to learn. It is quite unlikely that you'll come either into any industrial position or even a national lab where you'll be doing the things precisely that you've done before. They're looking for something, your background is slightly different, at least, and the same happens with students, either students with some undergraduate background want to join graduate school, or postdocs come with some background in their PhD. It is quite unlikely that what they will be doing in their next phase of their career is exactly along the same path as they have pursued before. And for me, the most important criteria is, can I assess whether this person can learn and become an expert within the field. And I think most industry, and particularly today, the quantum industry that's fairly young, there is tolerance for letting people learn. There is an understanding that people are going to be coming, and I think this was touched upon by several of the panel members. There's an understanding that you're coming with different backgrounds. And so really, I would emphasize my ability to learn. This is a big, big plus that you can demonstrate that.
Yeah, we also, we definitely look for that. We look for people who are just smart people, and we like to see people who can communicate well. And this is speaking from the perspective of a national lab now. People who can communicate well, and whatever you've done in the past, you've done something fantastic. So present that and show, over this period of time, maybe it's 5 years or 3 years, whatever it was, this is the fantastic thing that I did. Right. And that tells the hiring committee or the people that are trying to hire you that, you did something amazing. Right. And it shows that you can learn, as Amir said. And then, based on that, the committee will decide if there's overlap with what they need you to do. But generally, we're looking for people who are smart and trainable and want to learn, enthusiastic, able to communicate, want to work on a team to achieve something that hasn't been achieved before. And that's what we're looking for. Yeah.
So one of the ways in which hiring works, let's say on my end, is there's an initial resume review. Then, assuming there's interest on that front, then there's an initial, let's say, 30-minute call just to get a sense of, it's a screening call. So, it's hard to, that initial resume review, it's really difficult sometimes to make that call, whether you dedicate that time to take that 30-minute call or not, because you get sometimes a lot of resumes coming in. So as Will just said, do your best on that resume, or whether you submit a cover letter as well, to convey that even if it's not quantum information science, convey that you've done something amazing. And then if we do end up getting on a call, what I like to hear, in addition, when we're speaking to some more details on what you did, is why are you really interested in QCI and quantum information science? And I'm looking for kind of that in-depth interest about why quantum is interesting to you, why you're interested in the mission and what we're doing. And I think it's that kind of dedication, either to the field or to the company, or to the work that you've done, which is really important, and gives me a sense that you'd be dedicated and really excited to join the team. So.
Yeah, I completely agree with you, Andre. I as a PI in academia, I can say the same thing. We get a lot of generic emails, which don't show me that people have read the papers we write, or at least some of the papers, and they don't know exactly what we do. So saying something about, what you've done that is important, and presenting this correctly and succinctly also, and also showing that you have taken the time to research the place you're applying for. I think that's kind of a globally applicable skill to have when you apply for jobs. So related to this discussion, maybe we can discuss a little bit non-technical skills that you have benefited you, and what you think are important non-technical skills for junior people to have and to cultivate. And someone specifically asked communication skills in industry, national labs, academia. What is the balance of technical and non-technical skills? So this is kind of a multi, component question, but maybe you can take the opportunity to give your thoughts.
So for the first thing, I'd like to be, I'm not sure I kind of even know what the boundary is between technical and non-technical skills in some way, right? Because science, for me, is an innately social enterprise. And, our goal in it is to, make contributions to society as a whole, as well as also to the scientific society. And if you're an utterly brilliant person, but you're unable to communicate your ideas, then you're not kind of really doing effective science. So communication to me has always been really a crucial part of what at least I consider personally science in my own model. But the other aspect for it that you've got to consider when you're making this next transition is the fact is when people are interviewing you is that there's often a lot of question substitution that ends up going in. And this is a term that I took from this book, called Thinking Fast and Slow, which I recommend taking a look at. It's a lot of fun. But in any case, what people often are, they're trying to find the best applicant, usually for a particular position. But often the question they're asking is, which applicant do I feel most comfortable with? Which is a slightly different question than the other one. So in terms of success, I think it's very important to be able to learn, right, how to be comfortable in these in weird, contrived interview situations, and also to give this sense that if I'm hiring you in industry in particular, most industrial roles are not limited term employment. It's long-term employment. And so that's kind of like, it's like committing to a 5+ year marriage and making sure that, you put a face forward that the other person feels comfortable with is really important. And I find that the only way that I've gotten good at doing that is utterly failing over and over again in attempts. So I'd recommend, especially if there's a position that you're really excited about, interview somewhere else first. Because that'll give you practice. It'll make you more comfortable, less awkward. And when people are seeing you on the other side, they'll feel more comfortable, and they'll be much more likely to see the good aspects of you as a candidate than otherwise. The other thing that I'd really recommend for this is that, recognizing, how to work well and build collaborations between different areas is vitally important. So there are people in the field that I know who are not actually, if you take a look at their raw technical strength, they're not actually all that necessarily great in any of the fields that they individually touch. But they're amazing scientists, because what they can do is they've got enough knowledge that they can translate between different fields and bring people to a table together. That's another really valuable skill, apart from that long term, that can be extremely vital in a multidisciplinary field. I don't know how to refine it, but if you find good ways of cultivating that skill, of building teams around you and using diverse people in ways that other people wouldn't be able to do, that's a way of getting success, and very different types of success than you would normally think.
I can add maybe a few things. I think generally I agree with what Nathan has mentioned. One thing to emphasize is that, oddly enough, the qualifications that are needed to get a job are not necessarily the same qualifications that are needed to be good at a particular job. And you need to navigate this dichotomy and emphasize those components that are important for getting the job, while remembering that eventually, you'll be doing the job, and what's needed there is different. And I think Nathan gave a few examples. I think one also important aspect to remember is that, being good is a multi-dimensional thing. It's not a linear, it's not a one-dimensional thing. It's not that you can put everybody on a single scale and say, I'm better than that person. And Nathan gave, great examples, somebody who's very collaborative and can borrow from one field to the other, somebody who's extremely good analytically and actually not very good in communication. But nonetheless, this balance, this vector is pointing somewhere differently on this multidimensional space, and yet, on some projection, that vector is the longest. I think generally you'd like to, emphasize where your strengths are, while, maintaining the understanding that, you want to present something that is consistent with what whoever you're applying to is looking for. It's a very, very complicated process. I think, yes, you can identify some of the skills that you'd like, communication skills, writing skills. These are all important, but not everybody has them, or not everybody excels in them, and that doesn't mean that you're not going to get a job. I think you just need to emphasize those things that you're really strong in, to compensate for the things that you're not so strong in.
Yeah, dittos to all that. And maybe what I would add in these interviews and discussions that you have is to be genuine and to be enthusiastic, right? Like, we don't, as hiring managers, right, we don't expect that you're going to come in and be 100% overlap with what we're looking for. We know that. And being able to articulate clearly what you've done and why you think it's important and your enthusiasm for this job and what you would like to achieve, I think, goes a long way. And so being genuine and enthusiastic is a good quality or soft skill to have.
Yeah, Andre?
Yeah, I think once you are on the job, I find that it's very important to accept the feedback that you're given. Especially when transitioning from an academic to a commercial environment, which is very different in some respects, where the audience that you're trying to address can be very different, especially in the quantum sense, where you're trying to sell a product that can be technically challenging to understand, features that are challenging to convey. For people who have been at the company for a while and who have garnered that experience, brand new employees who are coming in and who have yet to learn that, please, be open to accepting feedback on how to do that, because it is a skill that isn't always innate. It can be, but sometimes it's acquired, and with enough practice, you can get it. And it's just something that you might need to learn. So be open-minded.
I completely agree with Andre. And also, I kind of want to propose that you can cultivate the skill of accepting feedback and being mentored, right? Because your supervisor, whether you do a master's or a PhD, or even if you're an undergrad, they are there to mentor you and help you. But oftentimes many people are not very amenable to feedback, and they view it as criticism. So I think even learning how to take feedback, even when it's not, the flattering things you want to hear, and taking it and improving the things that you're being, criticized about, that's an amazing skill to purposely cultivate, and it'll serve you very much, I think, later in your career as well. And that kind of, ties to what Andre said. Then you'd be ready to view this as an opportunity for self-improvement rather than, something that you have to fight against. So there's actually a question that I would like us to take. I'm also curious. So one attendee asks, what are the best and worst parts of your jobs as academics? Do you miss the hands-on aspects of being a postdoc or grad student? And what do you consider important questions to ask yourself when considering a postdoc to faculty transition? So maybe Amir can go first. He has a hard cutoff at 3, so we can start with you.
Sure. Well, I'm not sure everybody is going to share, the things that I hate most about my work, but number one, I hate writing grant proposals. Absolutely hate it. Even I hate more writing the reports for the grants that have been awarded. Number two, I actually hate writing papers. For me, the point where I come to write a paper to publish the work that we've done, I'm already bored because I know what I want to write in there. We've done it. I'm kind of focused on what's the next project, what's exciting. Having to spend time and polish all the wording, etc., is not great. as you can see, it has to do a lot with writing, and this is obviously my weakness. I'm not a very good writer, and it translates to the things that I don't like doing. I don't know if the question included what I do like to do, Sophia.
Absolutely, yes.
Okay. I love interacting with students. I see myself as a collaborator. There's obviously mentoring, but the mode of operation that I usually follow is having frequent discussions with students, sometimes even multiple times a day, and basically pushing the work along in a collaborative fashion, through brainstorming, etc. Okay, so this is what we know now. What should we try next, etc. So this is the thing that I really like the most in our work. I also love, as I mentioned earlier, putting myself in uncharted territories, at least for myself. So and the reason my group is kind of proliferating is because I very frequently like to start new projects, things that I know very little about, and I very rarely close down old projects. So it has this kind of fractal nature. But yeah, these are the things that I enjoy.
Great. Do you want to also address the second part of the question, which was, what do you consider important questions to ask yourself when considering a postdoc to faculty transition?
Right. So I think that when considering a transition from, number one, it's really important what is, as a postdoc transitioning to a faculty position, you need to come up with a research program that you're going to be proposing and essentially following in the first couple of years. And I think identifying that is not easy. And I very much recommend postdocs in my group who are at that phase to take a month, take 2 months, do a lot of literature search and reading, and primarily try to incorporate all their past experiences in coming up with something that is unique, that is really unique to them, because nobody else has their specific combination of past experiences. So I think in terms of figuring out what to do in research is number one. Second, most academic positions care about teaching. So coming up with a vision for what it is that you'd like to accomplish as a teacher, as an educator. I think many institutions will care a lot about that vision. Yeah, let's see if there's anything else. I'd say these are the 2 most important ingredients.
Nathan, do you also want to comment?
Sure, yeah. So for me, the worst part, I gotta admit, is grants. No doubt about it. That sucks. I don't mind the writing process, but I think it might be a little bit different with my experience, because I hated the writing process, because I at first when I started all of this, I was an awful writer. Now I'm merely a poor writer, so it's gotten a lot less painful. But in any case, for me, I always felt that the writing was part of the research. This could be a theory experiment dichotomy, but often, it's only when the ideas show up on the paper that the places that I didn't understand the ideas that I thought I understood them end up starting to become apparent.
I agree. Yeah.
So at least in my world, I really feel that that's part of the whole thing. And I really do feel like the publication, or at least posting on the archive, is kind of like giving my ideas a sense of immortality. So to me, that's something that I really crave and love. But the thing that I would say is the actual best part is, like Amir says, it's working with students. And that was relative to my industrial and national lab experience. Being able every single day to mentor graduate students and help them with their research problems, that's fantastic. That's really why I do it. And I really like teaching myself. Some people don't, but for me, that's also a source of energy, teaching and learning random subjects sometimes that the department views for some reason that I'm qualified to teach. But those are all great things. I would say that, when you're thinking about the transition from postdoc to faculty, right? unfortunately, there's some kind of like life questions that you've got to ask, right? One of the big life questions, of course, is the nature of the whole two-body problems that you might be running into. Because when you apply for faculty positions, who knows where you're going to eventually end up landing a position. And often the biggest restrictions end up coming in from transplanting the rest of your life, is in your family and everything else, to potentially, in some cases, another continent. And asking yourself, okay, well, if I'm willing to do this, and in some cases, right, when you do the transition from postdoc to academia, not all places are equally good at promoting assistant professors onto a tenured position. There's a number of places, particularly certain Ivy Leagues, where it's very, very rare for people to be able to successfully make that transition. And in that case, you might have to move again. And sometimes even after that, a lot of professors end up moving in their positions. So you're kind of like expect to move a lot if you want to pursue that path. If some of those options don't look all that satisfying, then those are reasons to consider in industrial or national lab positions that tend to be a lot more geographically stable, and often, you can end up landing positions like that in a major place that's easy to bring your family and the rest of your life to. So really kind of just ask yourself a question about whether the academic lifestyle in the particular city that you're taking a look at, like for example, in my case, I had an amazing offer that ended up coming when I was looking for a position at a university in Illinois. An amazing university. I loved the university, but my wife let me know very quickly that it was a choice between that university and a divorce. So, given the choice between the two, I went with the lab and the University of Washington position over that. But you got to ask yourself what kind of life you want, and every university has a different trade-off.
Yeah, also, Will, the same question, and also maybe we can also ask the other part of the question, which was, do you miss hands-on aspects of being a postdoc or grad student?
I can answer that quickly. At least for me, I don't spend as much time hands-on as I did once upon a time, but I spend a couple of hours a day doing that, and that's enough to scratch my itch.
Well, what about you?
Yeah, I certainly enjoyed my graduate school time, and I definitely, love being in the lab, and I love that moment when things work and the discovery happens or the result comes out. That's great. But of course, I'm in a different place in life now, and I want my students to have that experience, and my postdocs, and of course I can share it with them later. But I wouldn't say that I would want to go back to that time. I don't miss it in that way. I miss it in that I remembered it and it was a great time and I enjoyed it. And now I'm doing something else that I enjoy a lot. So that's what I would say there. And what everything else that people said, I think I would agree with. Writing grants is not my favorite thing to do by far. I do like writing papers, and in fact, I view them as part of the creative process, right? And in the science, along the lines of what Nathan said.
Yeah, I'm actually doubling down on that. I actually also like writing proposals that don't have deadlines. So to me, I view that as an opportunity to catch up with the literature that I've been meaning to catch up, and maybe I've put aside because there's so many deadlines. And I view it a little bit like an indulgent period where I can get to read papers, read, a reference in a paper, and then go to another reference that paper cites. And, adding that element in makes it much more enjoyable. All right, so I think the work-life balance comment that Nathan made kind of, resonated with a few people. So I don't know if there's any other comments on that, if anybody wants to make any comparisons between different jobs or just general statements about work-life balance.
I think work-life balance is obviously very important. It's essential for the morale of the team, for the productivity of the team. You want your team members to be happy. You want you to be happy. So, yeah, I think it's a very important question you need to ask about when you're interviewing, and make sure that the interviewers are giving you an honest answer. So yeah, take that as a very serious consideration, because it will impact your personal life, especially if there are multi-body factors to it. So yeah, it's absolutely essential.
And maybe, I don't know if Nathan or someone else wants to comment, do you see a difference between jobs in the different, academia, national lab, industry? Nathan already alluded to this, that you have a little bit more choices if you don't go with academia.
So one of the things that I'll say is that, apart from the teaching aspect of it, there were times in industry when my experience was almost identical to this. When I was mentoring students over the summer who were interns coming in, it really felt not much different than it feels being a professor at a university during the summer at Microsoft Research when I was there. But that's a very particular experience. And as I said, there's a wide diversity of different experiences that people can have in industry. But I guess the way I look at it is that if you go down, industry and to a lesser extent, the national labs, if you wait long enough, just about any experience you want to have happen will likely end up happening. So, yeah, to be honest, at times it's not that much different really across each of them. The key thing is, for me, do you like the work you're doing? Do you like the place you're living? And do you like the people that are around and above you in the chain of command? And if the answer to all of those is yes, then in my experience, it feels often like all of those things are kind of ultimately the same.
And maybe one thing to add about work-life balance is, of course, we often think about it in terms of our own work-life balance, but as you get into positions where you're managing other people and teams, it's actually something that you can impact quite a bit. And so you get to set the direction for the work-life balance of your group and of the members of your group. And it's important to think about how you want to do that, right? And in our group here, we take it pretty seriously. And so you work hard. I encourage people to work hard and to play hard. And when you need to take a break, take a break. And come back rested, right? And you'll have that ability when you're managing a team in the future, whether it's in academia, industry, or national lab, to help to set the tone or the culture of your group. And it's important. Like Andre said, you want people to come to work who are eager and ready to get going and happy. And that's definitely related to work-life balance. And it changes throughout our lives, of course. When you start a family, then the balance shifts more towards the family. There are other times in your life, when you're trying to get tenure, it's going to shift more towards the work. And that's just the nature of the career pathways that we choose. But you'll have an ability to influence other people's work-life balance.
So I wanted to, one additional comment on this, relating also to, what some of the things that I miss as being a graduate student or postdoc in relation to work-life balance, is actually having time to waste. I think really an important aspect of the creative process is random walk, is basically, doing things that, if you didn't have time, you would do it. But it's really important to have time to do this random walk, because it really gets you to unexpected places. So as life gets busy, and I remember for me, this changed dramatically when my first child was born. I suddenly realized I have far less time to waste. I think it impacted negatively my ability to do creative science. So what I encourage everybody is to find this balance and find some time to waste. Make sure you have this time to do other things where your mind, walks randomly and just have time to explore other thoughts. It's going to impact your work in ways you would not expect. And with this, unfortunately, I need to leave this panel because I have to go to teach. It was nice serving on this panel with you all.
Thanks a lot, Amir.
Bye-bye.
If you get a dog, then you can. If you get a dog, then you can random walk outside every morning. So that's a good excuse.
So since we're running out of time, I promised we would kind of touch up on the startup world. And I think for many people, that's kind of a mysterious world that they don't know how it works. So maybe, Andre, do you want to give us a little bit of a kind of a general view on how you even start a startup, and what how do you talk to venture capitalists, and how do you raise money, and then what happens, and what's Series A, etc.
Yeah. Well, that's a whole lot to dig into in just a couple minutes, but I think as we've gone through throughout this session, and as members of the panel have pointed out, there is a lot of overlap with academia and the national labs process. You are raising money. You are trying to build something using that money. You're getting it from different sources, and the timelines are different, and the promises and the goals are different. So I think one of the things that's really exciting about startups is that, especially when you're coming in very early, is you're wearing, so to speak, many different hats, and you kind of have to. There are many things to do, and typically, as you're still building up the team, there aren't as many people to do them. And so in my case in particular, there were software teams, or there was a software team to manage, there were products to define, there was a website to build, there were a bunch of things that all had to get done kind of at the same time. And so multitasking was a really big part of what needed to be done. Raising funds, as I said, it's pretty kind of standard, Series A, Series B, Series, C, D, and so forth. I got started at QCI as a quantum control electronics engineer. That was based on my work in graduate school, and I ended up working with with QCI's co-founder on the actual pitches themselves, and I ended up joining him on the road to and contributing to the actual pitches to the venture capitalists. And so it was the opportunity of a lifetime in a lot of ways. And so I think that goes to show that at a startup, you join and you are hired into a position, but sometimes you never know where that's going to lead. And going back to this point of wearing many hats, you might be called on, asked upon, or you might just grow into a slightly different role than you expected, and often with very good outcomes, often with very positive outcomes. And you have a lot of ability to influence your role, because the organization is still very small. It's growing organically in a lot of ways. And there's still a lot of flexibility, as people are building a business. They're trying to figure things out. They're trying to hit milestones. And so it's a very energetic and vibrant environment. So there isn't too much, honestly, there isn't too much mystery about it. You're building a company, you have a budget, you have the buy-in and trust and energy of very smart venture capitalists behind you, who have put in a lot of their money, just like funding agencies, but the goal is commercialization. The timelines are a little bit shorter than they are typically for grants, in my experience at least. And you're building a product that you're hoping to sell, and you have a mission that is big and profound, and that's what the promise of the product is. And so quantum computing really fits into that.
Thanks, Andre. So we have a few minutes left. I don't know, Diana, do have a hard cutoff at 3? Should we take maybe a few more questions and then wrap it up?
I would take one more question, one more or two, because then people
Okay.
are going to go to the exhibit booth.
So there's one question that I can answer quickly, which is, as a grad student, how do you get experience in grant writing, since that is such an important part of our industry? I would say ask your PI. They'd be very happy to have your help. Definitely, ask them to help. That's an easy one. And then the last one is, how do you deal with, if applicable, with feelings of imposter syndrome? And thank you for the frank and honest discussion. So maybe if anybody has something to say on that, and then we can hear your final thoughts and wrap it up.
Yeah, sure. I mean, I think speaking for myself, I've had imposter syndrome many times during my career. And I think it's a natural feeling for people who have some degree of self-awareness to always be asking, am I good enough to do this? But despite having felt that, my advice would be to don't let it paralyze you, but to take on a challenge and do your best, right? And accept the fact that you will make mistakes in your new position, right? It's going to happen, but you would not have been selected for that position or that opportunity had people not seen in you the ability to do that job, right? It's an opportunity that you earned, as well as people recognize that you're a good match to that new position. And so that would be my advice, is that first, know that you're not alone. A lot of people feel this, right? And I, for one, have felt it many times as I've advanced in my career. But that you will do okay. You should get into it. Know that you're going to make mistakes, but you're going to do a good job, and just do your best.
I think that, when you take a look at it, it's not, I think that there's not a single person who isn't impacted by some form of imposter syndrome or something that looks like it repeatedly in their career. Like, every time you get a negative referee report back on a paper, every time you've got a grant application turned down, every time somebody says no to you for a job, right? Those thoughts are going to come back in. And if there's one thing that happens at a constant rate or a nearly constant rate, in my experience, is some form of minor rejection in academia. And I find that, even though imposter syndrome is I think it's pretty universal, and no matter what you try, what I try, there's no way I can fully inoculate myself from it. But the thing that I definitely think is a common feature about the people who make it is that often people who tend to be successful in these areas aren't brittle. They tend to be the type of people who will feel awful. They'll feel disgusting. They'll wonder if they ever have another good or creative idea in their life. They'll go out, they'll have a beer or two, wake up the next day, and, well, just keep trying until eventually, yeah, that cool idea ends up happening. And so, to me, that's really the skill that I think, is worth cultivating, helping build up that inner reservoir, and that keeping that voice in your head to say, hey, I felt like this before, and I got through to the other side of it. And that, to me, that's what's needed in order to have the guts to deal with a field that has so much rejection as science.
Thank you, Nathan. Andre, do you have a last comment before we wrap up?
Yeah, no, just echoing the fact that both in academia and in either industry or the startup world, same thing happens. And as long as you can pick yourself back up and keep trying, and you don't give up, then you're always going to feel it from time to time, but you need to not give up, and that's how you get beyond it.
Great. Thank you all. I think this was a really nice discussion. I actually enjoyed it. Thank you, Diana, for everyone for being here, and Diana for setting us up here. And I think this concludes this discussion, and I would urge everybody to go to the booth and interact with people more.